Welcome back. We'll be going into position vector and vector forces, which is from the textbook page, from the textbook chapter 2.7. At the end of the class, you should be able to represent position vector in Cartesian coordinate form and represent the force of vector directed along a line. Yeah. So, application. Like example, this ship mooring line, connected to a bow, so can be represented in a Cartesian vector. So what are the forces in the mooring line and how do we find the direction? So with position vector, you'll be able to actually find the direction and the force itself. Yeah, I'll explain to you shortly how can it be done. Okay, like example, if you go anywhere along, you walk along the street or something, you can see like many structures is being rested. All these are actually vector. Yeah, of course at not all time you can just take a graph paper here and then you put a coordinate and then you find put a graph paper, climb up there and take a ruler, and measure. You can't do that. Yeah, so this is where the position vector comes in. Yeah, how to solve this? Okay, when you, not all the time, your vector starts at 0 0. Okay, like example, you yourself, when you travel from home, your home is actually a reference point where I would take your home as coordinate 0 0 0. But not all the time you actually start from home, right? There are sometimes you come from home, from your home you head to Sunway. Okay, then from Sunway maybe you would have gone to Mid Valley Mega Mall. Okay, so from home, let's say it's 0 0 0 and coordinate Sunway is 1 2 1 example, and maybe Mid Valley is 3 5 6 example. So what we have now, not all the time you start with 0 0 0. Sometimes your journey can just be from Sunway to Mid Valley. Yeah, so when is Sunway from Mid Valley, Sunway has its own coordinate, whereas Mid Valley has its own coordinate. Yeah, so that's where this case comes. Yeah, so look at this A. A is in a mid-air somewhere which is not at 0 0 0, and then we have coordinate B. Okay, so A has coordinate, its own coordinate of x, y and z. Yeah, x A, y A and z A, whereas B has its own x B, y B and z B. So both of them has got their own coordinate. Now, how do you find the position vector? It depends on the direction of the arrow. Like in this direction, can you see? The arrow is actually starting from A to B. So because it's starting from A to B, you take the final coordinate of x B minus with x A. That would be for your I. And for your j, it will be yb minus ya, and for the z, it will be zb minus za, just because the direction is actually from A to B. If the direction is in the opposite side, then you have to reverse everything that you have done. Okay, so I hope you can understand what I've just done. Okay, I'm going to go to textbook. This is where it is from the textbook, and if you see the textbook, they have actually given the formula in I, J and K. So you look at this example. A has its own coordinate and B had its own coordinate. So now it is actually from A to B. So if A to B, you take coordinate B, you minus with A. Okay. So we have done this part here. Now let's move to the example. Yeah. So for example, I'm going to move on to here, which I have copy cut paste here. Okay, let's look at this. Now A has its own coordinate. Okay, let's find coordinate A. So what is coordinate A? You have to look at it carefully. Yeah. Okay. So what we have here, it is okay. This is x direction, and then we have y coordinate. So it is actually at 0 y. Because it's the plane is this plane. It's at this plane. So this plane is between x and z. You don't have the what you call the y coordinate. Yeah. So this would be 1, 0, 1, 0, 3 at the bottom, negative 3, right? Because it's at the bottom, yeah. Okay, so that's coordinate A. Now, coordinate B would be, where is it? It is negative 2 at the back of X. Can you see that? So, this will be negative 2, comma, and then we have for Y, we have it from here, that would be positive 2, yeah, positive 2, okay, and then we have Z hiking up at 3, okay. So, if you look here, the question is asking, elastic rubber attached to the point A and B. Determine the length direction measured from A towards B. So, if A towards B, what's happening? Yeah, how will the arrow be? If A towards B, it's from here to here. So, your working will be, you take all coordinate B minus with all coordinate A following the IJK. Yeah? You cannot just take whatever that you like. So, you have to take I with I, yeah, negative 2 with minus 1, yeah, and then the Y, 2 minus 0, and then we have the 3 minus 3. Okay, so finally, your direction, yeah, your direction will be negative 3 to 6. Okay, so how do you find the magnitude? So magnitude means the length, yeah, because all this coordinate is actually given in length, right? So in real life, you cannot be taking a ruler or taking a measuring tape, climbing several staircase, or if you don't have staircase, it's elevated somewhere high up. And this is how you do. Yeah, you try to sketch them from ground. Yeah, just place in coordinate, estimate, and from there you can find the length. So what will the length be? Square, 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 see, and inverse square root. So that will be 7 meters. Now, if you want to find the angle, what do? You take the 3, the negative 3. I've scribbled so much, I'm going to erase this. Yeah, you take the 3. You take the 3, the negative 3. Okay, you divide by 7. So 3 divided by 7. Remember, it's negative, yeah? So, you have to follow the negative, huh? Okay, that would be, inverse cos will be for alpha. And then we have 2, positive 2. Positive 2 over 7, yeah? The magnitude of 7 here. Okay, that would be your beta. And the last one, you take the 6. Okay, you take the 6. Okay, you take the 6 and you divide by 7, so you get 6 over 7, you get the alpha. So which means at the end of the day, the resultant of the rope, yeah, the resultant of the rope is at 7 meters length and an angle of alpha, beta, gamma. So alpha is from axis X to your resultant, and beta is axis Y to the resultant, and axis gamma will be axis Z to resultant. Yeah, so this is how you complete the working. Okay, now I'm going to move on to 2.8 from your textbook. Yeah, 2.8. Okay, let's see. 2.8, we have done this, the position vector. Okay, force vector directed along a line. So, if a force is directed along a line, then we can represent the force vector coordinates by using the unit vector and the force magnitude. So, let me just guide you with an example of what does this topic means. Yeah. Okay, I'm purposely skipping the examples from the from the PowerPoint, because I'm going to go to tougher one from the textbook. So we have done this. So we'll be moving to the next subchapter, which is force vector along a line. Okay, we're going to move to example 2.11. So this would be example 2.11. I bring it down to Word. Sorry, 1 second. Okay, let's work on this then. Yeah, example 2.11 from your textbook, it will be page 60. Okay, so we have this man here. Pulls a cord with a force of 350. So he pulls the cord with 350, represents this force acting on the Cartesian support A. So A, yeah? And determine its direction. So how do you do? The first thing to do is to find the coordinates, right? You repeat back the working that you have done in the previous lesson. Okay, so from A to this is from direction from support A, on support A. So the force F is shown. The direction of the vector U is determined from the position vector, which extends from A to B. So rather than using the coordinates of the end of the chord, can be determined directly by noting the figure 2.37 that one must travel A, 12, negative K, and negative 4 and 6. Okay, I'm going to show you how do you get to this number shortly. Yeah, okay. Okay, let's look at this. I've actually written the coordinate for A, which is 0, 0, 15, and B, which is 6, 4, and 3. So coordinate B and coordinate A. Okay, now this question is actually taking which extends from A to B, which means the force is actually towards from A to B, because he's pulling, right? So he's pulling. So in this case, you have to take coordinate B minus with coordinate A. So you take B minus A, you get 6. Yeah, just to answer this question. And then you have 4 minus 0, which you get 4. And then you have 3 minus y is negative. Yeah, sorry. Yeah, y is negative because it's at the back. The 4 is at the back of the, okay. So that's why it's get negative 4. And then we have 3 minus 15. Yeah, 3 minus 15 will be negative 12. So how is the magnitude? Magnitude will be 14. How do you get that? 6 square, 4 square plus negative becomes square, it becomes positive. Yeah, so you get 14. So once you get 14, you can find the unit vector, which is what? Your I will be 6 over 14. Your j will be 4 over 14. Remember, retain the negative, very important. And then we have 12 over 14. So you get unit vector as 3 over 7, 2 over 7, and 6 over 7. Watch out of the negative value. Now, what does the question say? It says what? Now, you have found the unit vector, right? Okay. The question says the force that's imposed is 350. So, if the force imposed, the total magnitude imposed is 350, which means what is the force that is what is the amount of force that is distributed in I, in J, and in K? Very simple. You just take the 350, you multiply with the unit vector. So you can actually distribute them along I, J, K. Okay. Now, how do you find the alpha, beta, gamma? Once again, you take the vector. Can you remember this? Yeah. And then you inverse cos. Okay, I'm going to use a different ink here because I've scribbled so much. 3 over 7. There, inverse cos. And then you have 2 over 7. Watch out the negative. You cannot forget that. Inverse cos. Because the negative will actually give you it is negative sensitive because the angle, yeah, depending on the angle. Yeah. Okay. Can you see that? If it's positive, it's within 90. If it's negative, it goes beyond 90, but of course doesn't exceed 180. Yeah. Can you see all this? Yeah. So negative is very, very important. Yeah. Okay, so with that, I've ended this subchapter. So we will be meeting again in chapter 2.9 in the next video. Yeah, please finish up all the homework that I've assigned to you and upload it on the eLearn. Thank you.